Let's take a look at the basic ANOVA report. This is the MRSA regions data with the columns by year. Go to the Analyze, Fit Y by X. We'll put our regions in X and our 2011 in Y. This is for the percent resistant, and press OK. And we get a very simple plot. I'm going to change the size and scale of the plot so that we can take a little bit closer of a look. Right now, this plot is not proportional, so the group with the largest N is getting more space. That is the South group. You can change that under the display option, so you can remove proportional, and you'll see now that each X-axis group has the same amount of space. The overall mean for the 2011 percent resistant is this gray line. You can see that by doing a distribution on 2011, and the mean for that is 49.13, which is just below 50 here. So recall that our null hypothesis is that the best estimator for percentage of antibiotic resistant infections is the mean of 2011. Our alternative hypothesis is that there is a need for different means. It's not that we have all different means, it's that there's more than one different mean. So our null hypothesis is the mean value of 2011. Our alternative hypothesis is that we have more than one mean value. We're looking for a statistically significant difference across the groups, and we assess that with an ANOVA. The basic ANOVA assumes normality and equal variance. To assess that assumption, under the red arrow, under normal quantile plots, plot actual by quantile. Make this just a little bit larger here. We're looking for the same thing that we looked for in the normal quantile plot for a single mean. We want the dots to follow the straight line. Now here we have a lot of overlapping lines. The top group is the southern group, followed very closely by northeast, south, and west, and they're sort of a jumble, particularly west and the Midwest, the orange and red lines, these top next two lines, they're sort of almost on top of each other, and the green line is shorter. That's the northeast group, has the fewest samples, observations, has the fewest states. It's the shortest line, and it seems to be crossing the other two. However, we know that the 2011 group is normally distributed. We know that we have a large enough sample size to claim the central limit theorem. What we maybe don't know, because it's a little bit hard to judge, is normality per group, though the only large departure from a line I'm seeing here is in the west group. That would be due to this outlier. You would want to verify that's a true outlier and not an error. Assuming it's true, we'll leave it where it is. But otherwise, it looks relatively normally distributed. The next video will look at how to assess standard deviations. From here, we will proceed as if we have equal standard deviations. We can actually look at our standard deviations by asking for means and standard deviations. We can see here that there is an observed difference. We'll learn how to test the difference for standard deviations in the unequal variance ANOVA video. For now, we'll proceed with equal standard deviations, and we'll use the ANOVA test. So to get an ANOVA, we simply ask for the means ANOVA report, and that pops up here below our figure. We have the summary of fit report. It tells us how many observations we have. It tells us the overall mean. It tells us the overall variability. And then we have our R squared and adjusted R squared statistics here. Remember, the R squared tells us how much of the variance of the 2011 responses is accounted for by knowing region. So 29.87, or 30% of the variance in the 2011 antibiotic resistant percentage values are accounted for by knowing region. Our null hypothesis is that there is no difference in the means reported by region. Our alternative hypothesis is that there is a statistically significant difference by region. We look at our f-test. Our f-test gives us a p-value of 0.0034. This p-value is small compared to our alpha. Therefore, we reject our null hypothesis of no difference and conclude that the means by region are statistically significantly different. You can report the F ratio and the p-value. You'd also want to report the means. Note that this is a pooled error variance estimate test. So you simply say by ANOVA or by f-test, and the assumption is that it's equal variance. We've assumed normality. We've assumed equal variance. Our null hypothesis is no difference. Our p-value tells us that we have a difference. We would state we conclude a difference. We'd give the means, the ends, probably the confidence bounds about those means, and then report our results in that manner. Up next, we'll look at assuming normality, but not wanting to assume equal variance, followed by not wanting to assume normality and using a non-parametric test.